is. Okay, so when we are working with calculus, we have what we call a limit. So it means that h, the variable h, is moving towards 0. Okay. En die maklikste manier om dit te verstaan is om te dink aan 'n asymptoot. Now, grade 12s, if you don't understand this, you are only going to apply it. You don't need to explain this, so don't be discouraged by this. But if we look at, for instance, our exponential graph, okay, and if I zoom in here, you guys know that the x-axis in this case is the asymptote of the graph. So wat ons sê is hierdie lyn neig na 0 toe. Will it ever be equal to 0? No. But at some point, it's going to be so close to 0 that in practice, you can regard it as 0. Okay? So at some point, it's going to keep on moving closer and closer and closer to y is equal to 0. But at some point, you can say that this distance, if we zoom it back out, where's 100%? You can almost regard my line as being on the x-axis. En onthou, hy gaan nou nog verder gaan. Keeps on getting closer and closer and closer. Totdat jy op 'n stadium, maak nie saak hoeveel keer ons inzoom nie eintlik meer kan sien dat daai lyn nie raak aan die x-as nie. So do you see, it isn't equal to 0, but it is so close to 0 that in practice you can say it is leaning towards 0. Dit neig na 0. And it is so close to 0, it is basically 0. It isn't 0, but it is so close to 0 that it is basically 0. And that is what we are going to work with. So at some point, once you've done enough in your calculation, you're going to say, let's cut the crap and just admit that this is basically 0. So I'm going to set it equal to 0. But you are still acknowledging that it can't be 0. Verstaan julle wat ek sê? So wiskundig gaan daai ding nooit 0 wees nie, né? It's never ever ever going to be equal to 0 mathematically. But at some point it is going to be so close to 0 that for all intents and purposes we are just going to say it's my 0 and carry on from there. Okay. So that is what you're working with when you're working with this. And you're going to see this a lot today because that's basically what we are going to work with. Okay. So ons gaan werk met afgeleides. Nou, toe ons inverse funksies gedoen het, het ons mos gehad f van x. En dan was sy inverse geskryf as dit. Né? Okay. Not to be confused with what we are doing now. If I have f of x, dan is sy afgeleide. You write it like this. Note the difference in notation. The one has it to the power of -1. This is actually f, and then it's like a little dash thing. Derivative. I do not know if I spelled it correctly. DI. No, it can't be derivative. Oh, yeah. Spell? No, from the beginning. Is the rest fine? I don't know either. Derivative. Is that fine? Okay. And then later on, when we feel better about what? DERI Okay. Hopefully for the rest of the remainder of this, I'll be fine with that. Okay. Good. Die eerste afgeleide skryf mens so, but this is what's important to me, that you guys understand you're not writing to the power of -1 anymore. You're making it not a 1, it's like a dash. Because when we get to the second, now I got this. Then you're going to do this. It's got 2 dashes then. En dan is dit nie F11 nie. Dis die afgeleide van die afgeleide. A second derivative. So you're taking it to the second level. And we're only going to do 2 levels. But today I'm going to show you how to calculate this by using first principles. And I want you guys to write that down. So your heading is nope, that's not how you spell using. Now I don't know how to spell principles. I'm going to Google everything now. Principles. I Googled it. Yes, this isn't like headmaster. Headmaster is with an AL. Okay, en die rede hoekom ek wil hê julle moet dit skryf by die somme is dit is hoe dit vir jou gaan gevra word aan die einde van die jaar. They're going to say calculate the f dash x, meaning the first derivative of x, by using the first principles. And then you have to know you're doing this that we are doing now. Okay. Want hulle gaan vir jou op 'n ander manier ook vra om die afgeleides uit te werk. So you have to, in your mind, know that today we are only going to do first principles. Just applying first principles. Next week we're going to do the rest. And then there's another method that we follow. Maar vir vandag, eerste beginsels, eerste beginsels, eerste beginsels. That's the only thing we're using. Okay. Now, to save time, trust me on this. On your formula sheet. Well, you don't actually have to trust me. You can just take op jou formuleblad about should you be trusting me on this? Now I can't see it. Oh, I see it. First, second, third, fourth, fifth, 6th line from the top. It says that is equal to lim h to 0 that. It's written on your formula page. Okay. When you see the words first principle, as jy sien jy gaan eerste beginsels gebruik, dan skryf jy daai formule neer. Because that is the formula for using first principles. Okay. Ons gaan uitwerk if f of x, so this is what we're going to work with. And I ask you to calculate that if f of x is equal to x to the power of 2. What is f of x, x to the power of 2? Wat is dit? Dis 'n grafiek. Wat is wat grafiek is dit? Nee. Exponential is if the x is in the exponent. It's a parabola. Okay, this is a parabola that looks like this. Don't draw the parabola because it doesn't make sense now. It's a parabola. Okay. I just want to keep that in the back of your mind because later we are going to do the graphic applications of derivatives. Later, ander dag se worries. Vandag doen ons net eerste beginsels. Just first principles. Okay. Then you start off by saying, f of x was given to you as x to the power of 2. Dan as ons kyk in hierdie vergelyking, praat hulle van f van x plus h. Now we did something similar to this previously where we said that means that everywhere you find the x, you have to go right plus h. Nee? Nou julle ons het mos gesê gister toe ons hierdie gedoen het, toe was dit f van 2x. So oral waar daar dan 'n x is in die formule gaan sit jy mos 'n 2 voor hom. Okay, so we're going to do that. F of gaan weg. X plus h will just be x plus h squared. Sien julle, ek het oral waar daar 'n x is, net 'n plus h gaan bysit. Ja? Verstaan julle wat ek nou gedoen het? Almal van julle by? Okay. And then I'm just simplifying this. And that's your first step. Okay. Now we go and say, we know that to find the derivative, this is written on your formula page. En jy gaan hom later in elk geval uit jou kop uit ken. Don't be lazy with this. Write all of it out. I'm going to go and substitute this. Nope. Geen slange. I'm going to go and substitute this in there. Want sien julle dit is f van x plus h. Sien julle dit? And I'm going to go substitute this in there. Okay. Net dit gevat en dit gaan instel. Nee? Net daai twee vergelykings gevat en dit gaan instel. You keep on writing. Lim h goes to 0. I'm going to pay attention to that later. Okay. Nou gaan ek net die teller gaan vereenvoudig. So sien julle daai is x kwadraat en dan minus x kwadraat kanselleer mekaar uit. Do you guys see that? Okay, so I'm left with 2xh plus h squared over h. Stem julle almal saam die x kwadraat en die minus x kwadraat kanselleer mekaar uit. Ja? Julle die eerste een wat ons nou gaan doen gaan lank vat. You'll see the second one is going to be much faster. Okay. Now, I want to spend some time on this. Remember, we said h is going so close to 0 that it's basically going to be 0. Okay. Maar soos wat hierdie vergelyking nou hier staan, kan ek nou al gaan en sê, wel, h is so naby aan 0, ek gaan sommer net sê h is 0. Hoekom nie? Want in die noemer is daar 'n h. And what is one of the first things that you know about fractions? You are not allowed to divide by 0. So I need to simplify this to make sure I do not divide by 0. And that you do by using